Okay, this is going to be an exciting video because today we become programmers. Right? We've had a lot of information about the Linux command line. We know how to run programs. All of these programs we execute from the command line, like copy and move, they are binary programs that the computer processor knows how to understand. Okay, and we'll get into what that means here in just a second. So let's create a little file here. Let's CD to my desktop. We're going to create a little file here to take notes. Touch notes.txt. Okay, and we see that show up there. So I'm going to use the Atom editor, and the Atom command opens up the Atom editor, and what folder would I like Atom to open up in? That's // so this folder, wherever I'm currently working in my terminal, which is the desktop folder. Alright, so here we see we've got our notes here, and today we become programmers. Alright, so we're going to be learning about primarily about the programming language Python 3. Okay, so Python 3 is a programming language, and there are many different types of programming languages, but its programming languages are methods of creating software. Okay, and software is basically programs or applications. Or apps, right? So software is what communicates with the hardware. Alright, so software and hardware, what do these terms mean? Okay, hardware is the actual physical devices within your computer. Alright, there are some primary components that we need to be aware of. Alright, the CPU, or the Central Processing Unit. This is the brain of the computer. This is where all the instructions get executed. You have inputs and outputs. You input some data, it does some sort of operation like addition or creating a directory, and it outputs something. It communicates to the other devices, and you can create files on the hard disk or things like that. Okay, but the CPU is the brain. That's where all the instructions take place. Okay, when we do any kind of operation, especially you can think of mathematical or arithmetic operations, adding and subtracting, multiplication, division, all of this takes place in the CPU. You provide it two numbers and it'll do the multiplication for you. All right. Another computer component we need to be aware of is RAM, and that stands for Random Access Memory. All right. And you can think of this as short-term data storage. Alright, this is short term, which means it's volatile. Okay, it's short term because everything in RAM, as soon as you turn off the computer, goes away. Alright, RAM is very, very fast. Then we have a second type of storage, and that's called the hard disk. This is long-term data storage. Alright, this is non-volatile, and it's slower than RAM. Okay, so basically what happens, anything on your computer screen that you see, there's some component of it that's in RAM. Alright, even when we look at a file, if I cat some file, let me save this program real quick, or save this file, cat notes, what we're actually seeing here is stored in RAM. Okay, there's also a file on the hard disk that contains all of this data, but as we actively modify anything on the computer, we're doing that within RAM. and then we can signal commands to the processor to transfer the data from RAM and then store it onto the hard disk. Okay, the reason we have RAM and hard disk is because the hard disk is long-term storage. The hard disk is composed, older hard disks are composed of disks that have magnetized wafers on them, and ones and zeros can be stored on these wafers, but it's much slower than RAM. RAM is much, much faster. However, RAM requires electricity to be put to it at all times. Okay, so as soon as you turn your computer off, there's no more memory. Anything stored in RAM goes away. Okay, with the hard disk, you can turn off your computer. You can even transfer the hard disk to another system, and all of this data still remains. Okay, so this is long-term storage. You can think of this in terms of your brain. You've got short-term memory and you've got long-term memory. Okay, but it's slower. Sometimes you have to think a little bit to remember something in your brain. Okay, but the primary difference is RAM only works when there's electricity supplied to it. That's why it's volatile. The hard disk stores the data regardless of whether or not there's electricity. Now it can't access anything without electricity, but it's still stored. Okay, and then the last major component is the motherboard, and this basically just connects all of these components together. All of the components of the system. Okay, so these are the hardware components, all right, and we're talking about Python 3, which is a method for creating software. Okay, so what is software? Software is more abstract, okay? It is the ones and zeros, the bits of information stored in memory or on hard disk that understand how the CPU is architected, and it understands how to communicate with the CPU, all right? So the software allows us to write in a way that we can communicate with the CPU and all of the different components of the system. Okay, so that's the difference between hardware and software. And Python is a programming language. Okay, just like any programming language, there is a syntax. Okay, there's a syntax for English, Spanish, any kind of foreign language you may have ever heard of. There is a syntax, and the syntax is basically the rules of constructing well-formed ideas in a given language. Okay, so the rules of constructing well-formed ideas. Okay, and we're going to see a few different programming languages just to get you started, but this course is going to revolve around Python 3. All right, so let's get to our first program. Okay, so the first program is going to be called Hello World, and it's very common in virtually every programming language. This is the first program you make. All right, so we're going to do hello world.py. Okay, the .py is the extension for Python. All right, so let's go back to our terminal. We're in the desktop here, and I need to create a file. Hello world.py. Okay, and we see it showed up on my desktop there, and it also showed up here in my Atom editor. Okay, now this in Python, we're just going to create a text file. All right. The contents of this file is a series of characters. Okay, one character set we talked about was ASCII. Okay, so when I type the letter P here, that translates to the computer as a number, the decimal number 112. But the computer only understands binary. Okay, so this 112 in decimal gets translated to the binary version of that. All right. So everything in this file is going to be chunks of blocks of binary numbers, each of which represents one of these ASCII characters. Okay, so this is just a text file, and that's what it means to be a plain text file. All right, so to create our first program in Python, we use the print function, and then we pass in data. There's a few things I want you to notice here. Print, you can think of print similar to the Linux command line. Okay, all of these, print is what's called a function, and it's not that much different than a Linux command. You have the name of the command or the name of the function here, and instead of the arguments of the function being separated by spaces, instead all of the arguments go around or go inside of the parentheses. Okay, so we are calling the print function, and we are providing one argument. Okay, that argument is string data. String data is a string of characters. That means we're talking about ASCII data. We're not talking about numbers. We're not talking about arithmetic data. Ultimately, the ASCII data does come down to numbers, but it's a specific type of data. Now, when I use the quotation marks, anything inside that those quotation marks is considered by Python to be string data. Okay, so the quotation marks around anything is string data, and you see it's colored differently. There's lots of different colors in the different editors that help you identify what type of data, and it shows you the syntax, the rules of programming. Okay, so for this particular language, we're following the Python syntax. All right, now we're printing hello world, and all that's going to do is print to the terminal basically whatever we type here. All right, this is not that much different than a program when we use the echo command, right? Okay, and the pound character is a comment. All right, comments, this is something that the computer program ignores. Okay, comments are for humans. Okay, when I write a comment in the code, I'm trying to explain what I'm doing. This code is actually how I communicate with the computer. All right, and if I need more information about what I'm doing, because sometimes when we communicate with computers, it's hard to read it, this provides a human readable form that I can describe what's going on with this code. All right, but when I run Python, Python ignores this comment. Anything that starts with the pound character, anything after it is ignored on that line. And then when you go to a new line, Python is re-engaged and it will execute this code. Okay, so Python is an interpreter. It's an interpreted language. It's kind of in between an interpreted language and a compiled language. But basically what that means is when I run the command, there's a command called Python3, and then I run the command with one argument, that's hello world.py. So this opens Python3, and it reads this file one character at a time and figures out the commands that you are typing. You have to follow the specific syntax that you provided to it. You have to follow Python syntax or else you'll get an error. Python won't know what you're talking about. Okay, so when I run this command, it's Python3 space hello world. So over here in this terminal, we're back in Linux land. All right, so we use the spaces to separate arguments, and we just provide one argument. We're providing hello world.py, which is the path to our program. Okay, and we see when we do this, it just prints out hello world. Okay, because I followed the Python syntax properly. Now, what happens if I get rid of these quotation marks? Okay, Python does not recognize this the way we might think. If I try to run this code now I've had to save the file. Now Python complains. It says in the file hello world.py at line 2, syntax error, invalid syntax. So it doesn't like what we're doing here. So we have to be very careful about syntax. Computers are stupid. They do exactly what you tell them to do. Okay? So you have to understand the syntax in order to communicate with them. Everything in computer science essentially boils down to communication with systems and boils down to some form of numeric storage. All right, so everything in computer science is systems and numbers. All right. Alright, so everything in computer science boils down to systems and communication and numbers. Alright, so we've got our first program, hello world, and that's hello world.py. And notice here in Atom we have this blue dot, which means the file has not been saved. If I hit Control S, that goes away. So in my editor, I have fixed this. This is the correct syntax. So we notice the quotes around here. If I go back and I cat the file on the hard drive, hello world.py, we see that the quotes are not there. Okay, now this is important. What I'm editing here is in RAM. Okay, so this is in memory. I have not yet stored it to the hard disk. Okay, when I save the file, it takes all of the data in RAM for that file and then stores it on the hard disk in this file. So right now, whatever I've edited here in Atom is not yet saved to the file, which is why when I look at the file with cat, the quotation marks are not there. Now, as soon as I save this file, I hit Control S to save. So we see the quotes are here now. Now if I cat that, we see the quotes are there, and now we can run it. Okay, so it's important to know the distinction between RAM, memory, and then once you save something, that is the process of telling the processor to take whatever was in RAM and then store it on the hard disk. And all of that takes place from connections on the motherboard. Alright? So we've got this program, hello world. Now let's make another program. Let's make a bash program. Okay, so bash program is basically using Linux command line commands. All right, but we can do them one after the other. Okay, so I can make a file. And these normally have a .sh ending. Okay, so hello world.sh. Okay, so this is a bash or a shell script. That's why it's .sh. So there's many types of shells. We use Z shell. You can also use bash. Bash is very common. So I want to make hello world with Linux commands. And in bash, it's the similar comment syntax as Python. So this is a comment. Comments are for humans. Alright, hello world.sh. Now I can run hello world similar to how I ran a Python script. Bash is an interpreter as well. It opens this file and it has a specific syntax. It uses different syntax. We're already familiar with the shell syntax. The arguments are separated by spaces. Okay, so we say hello world .sh, and we see we get the same output. So this is, we now know the basics, well, a little bit about two programming languages. Python hello world, notice the difference in syntax, and then bash hello world. Alright, let's try another one. Let's try JavaScript. Okay, so we created this JS file. .js is the extension for JavaScript files, and it stands for JavaScript, obviously. Okay, now the syntax here is a little bit different. There's some similarities between Python but it's a little bit different here. So we'll look at the comments first. So we'll copy and paste this. This is a comment, but the comment character in JavaScript, or characters, is // Okay, so this is a comment in a JavaScript program. To print something to the console or standard output, we do console.log. And then you add a semicolon at the end. Notice in Python, we use parentheses like we did in Python, but we have to add a semicolon afterwards in JavaScript. All right. And in hello world.sh, we didn't need the parentheses at all, and we didn't need the semicolon either. All right. So this is hello world, your basic program in JavaScript. All right. So to run that, there's a program called Node, and it stands for Node.js, and this is installed on the CS server. And you just run Node, just like we ran the Bash script or Python 3. We run Node hello world.js. Okay, and it works. Now, what happens when we run Node hello world.sh? This is not a JavaScript file. JavaScript complains. It tells us this is not the proper syntax. Okay, if we run Python 3 and then the bash script, hello world.sh, invalid syntax. Okay, so you have to, depending on what language you're using, you have to use that language's syntax. All right, so let's do one more. And so Python and JavaScript are probably two of the most popular languages today, and that's because it's more you can communicate more easily in these languages. They're higher level. You can use more human-style communication to actually communicate with the computer and get the computer to do the things that you want it to do. All right. Bash is a much older programming language, and it's an interpreted language, and it is actually it can be very difficult to program in. Okay. But the nice thing about it is you can just run all of your Linux commands, and I could run another one under here, and it just executes them one after the other. Okay, so all of these programming languages do the same thing. They'll execute one line, and then the next line, and then the next line. Okay, so I've changed this, and I can run bash hello world.sh. And we see it ran the first line and then the second line. All right, so now we're going to do a compiled programming language. It's probably one of the oldest languages that has been used to develop so much software. It's incredible. All right, this is the C programming language. All right, so what we're going to do is we're going to create another file. Hello world.c. Now you'll notice how different the syntax is for C. It's much more difficult. All right, to do something as simple as printing something to standard output, that's something common to every single program. This is how you do it in C. All right. So first you have to include a special library, standard IO, standard input output. Okay, so this is how you include additional tools into your computer program, and this is a C program. Every computer programming language has a way to import other libraries, other tools. All right, so we have to import something right away. We have int main. Now in this one, this is the comment. This is similar to JavaScript. This is a comment that the program ignores, and comments are for humans. So notice the comment characters are the same as in JavaScript. And in Bash and Python, the comment characters are the same. They're the hash symbol. All right. Just like in any other language, like English and Spanish, there are similarities, right? There are nouns in all languages. There are verbs in all languages, right? So all of these languages have common components. And once you understand those components, it's easier to move between all of these different languages. And again, for this course, we're going to focus on Python 3, but it's good to know how to do some of the basic stuff in all of the languages. All right. So already we see that this is much more verbose. Printf. And again, we have the string characters to tell the program that we are typing string characters. This is a string literal. We're literally typing in the string in our program. And we say hello world, exclamation point. Return 0. Okay? So the C programming language is very picky about types of data. This function is like a command and it returns a value. What type of value does it return? An integer. And you have to explicitly return it. If you don't follow any of these rules, it complains. So that's, you can see just on the simple program, if we don't do any of this, we're going to get an error. Right? So in a C program, we have to compile the program first. So we say GCC to compile the C program, and then we say hello world.c. Then we have to specify an output file, and what do we want to call that output file? Hello world, with no extension. Or we could call it .exe or .out, okay? But we don't really need an extension here. This is a program. Just like the copy command is a program. Alright, so we see it created hello world. Alright, if we type ls-al, we notice here hello world is in green. Over here we have something interesting we haven't really talked about, and these are permissions. Okay, all of these other files, these first 3 bits are your user. This user, I'm logged in as Luke, I can read and write this file. My group, people who are in my group are allowed to read this file, but they're not allowed to write. And then anyone else is allowed to read this file. Okay, with this hello world binary that we just created, this translates the C file that was just a text file. This is commonly called source code. It translates the source code into a binary file that the CPU understands. Okay, so the CPU can run this file very, very quickly. It can't run the text file. First you have to compile it and basically translate it to something that the machine can understand. And this is called machine code. So this version of the program is compiled so that my particular processor and my architecture, my hardware, can understand what I wrote in this C program. Now Python, JavaScript, and Bash all do this in one step. Okay, but the older way of doing things, and this is at this point, over 50 years old, but it's such an amazing programming language. It works very, very well and has lasted a very long time. This was the original way of doing things, where you would write the source code, which is a text file, and then it would create a binary file that the computer processor could read and execute the instructions. Okay, so back to the permissions. My user we have this extra option X. We can execute this file. Alright? So to execute the file, I do / and I would like to execute hello world. Alright? So this is just like how we execute files. The copy command is really just a binary file that was probably created with C. Alright? So I can use the which command and see where the copy command is located. So the copy command is located in /bin/cp. So this is just a binary file like we just created here. So anytime we use the copy command, we're really just executing, more than likely, a C program. Alright? Now notice hello world here has this little % character at the end. Okay? All of these other programs automatically added a new line character. So when I print in hello world, it prints out whatever I type and then prints an additional new line character. The new line character is an ASCII character, right? Over here I believe it's called line feed, right? New line feed. Okay, so it's stored just like any other character, but it's special. When you display it in a text editor, the text editor or the terminal, it knows to go to another line. Alright, so again, one of the ways that C is a little bit harder to use is it doesn't do some of that nice stuff for you. We have to explicitly tell it, I want a new line character here. Okay, so we use the backslash because we're inside of a string here. This is a string of characters. We know that because of the quotation marks. If I wanted to print out a backslash here, right, I can't do that because the backslash has a special meaning inside of a string. The special meaning means, hey, wait, I want to specify a different type of character that I possibly can't type. I can't type a new line character in this string, right? If I do, it just makes my editor go to a new line, right? So I have to have a way of specifying what a new line character is. So the backslash is an escape sequence. It's an escape character. So when you're typing a string, you tell whatever programming language you're in, hang on, wait a minute, this next character is not the explicit character that I type. It has a special meaning. And this in, since it's a special meaning character, that means a new line. All right. So now this is going to print. Previously, it didn't print that new line for us, and now it's going to print it. We have to recompile. So I use GCC, I compile the C program, and then I have an output program, and I just overwrite the old one. Okay, so it overwrites, and then I want to run it because it's executable. All right, hello world, and you see that character is gone now. That means that there was no new line, but the command line wants to start a new line to keep everything, clean on your terminal. So it's telling me that there was no new line there. That's what that little % means in Z shell. Okay, so this is 4 programming languages. We've learned how to write the very first simplest program you can write in all of them. But notice how much more complicated it is in C. If I don't have any of this, any part of this aside from the comma or the comment, it's not going to work properly. Okay, now compare that to JavaScript version, Python version, and then this is just the bash script. Alright, and then one last thing to compare the differences between these files. Alright, I can use the cat command to look at each one of these. So I have hello world.py, that's everything that's in that file. Hello world.sh, that's everything that's in that file. .js, and even .c. This is the C source code. Okay. Now watch what happens when I just cat hello world. Okay. Cat looks at the file and it tries to translate it into ASCII characters, or a character set that cat is aware of. Right. So when I try to cat this file, we get all sorts of things that don't really make sense. Okay. The cat command is trying to interpret this binary data as if it were character data, but it's not. So whenever you use the cat command and you see something like this, you know that the file you're looking at is actually binary data. It's not a plain text file. Okay. Now you see some characters show up, and that may or may not be text. Right. It just depends. The cat command is doing the best it can, but it doesn't really recognize all of these numbers that it's seeing. Right. And when it doesn't, it prints out strange characters. All right. And so we can look at that a little bit further with the command Hex Dump. So let's look at this shows us the actual numbers that are stored on the hard disk, okay, in hexadecimal. Okay, and we'll learn why hexadecimal is so important. But you see hexadecimal in computer science constantly. All right, so we have Hex Dump, and we're going to look at our first program in Python.py. So these are the actual numbers, this is in hexadecimal, that are stored. So you can convert this hexadecimal to binary, and those are the actual ones and zeros that are stored on the hard disk for this program. And then each one of these, you see 23 is the pound character. If we look back at our ASCII chart, we can find the pound character. All right, in hexadecimal, 23 is the pound character. Okay, so in this file, it's just a series of ones and zeros. The next, there's no actual space in the file. They're just formatting this so we can read the numbers better. So it would just be a series of ones and zeros. And then the character, the hexadecimal number 20, right, is a space. So let's see, where's space on this chart? Up here, hexadecimal 20, there's space. Then we have a T, capital T character. And let let's look over here, capital T, that should be hexadecimal 54. And sure enough, we have a 54. So everything over here, it's translating these numbers, which is what's actually stored in the file, it's translating that over here to the character that that number represents. All right. Hex Dump -C, we can do that with the bash program as well. We can do that with the JavaScript program. Right, and over here you see the comments are different, the numbers are slightly different. 2F must be the character for slash, right? And then we look at C, and again, the source file for a C program is plain text .c. It's just a plain text file, and we can see that with this command. The numbers in there correspond to characters. All right. Now, what happens when you do hex dump -C on the binary file that was created? The binary file is formatted in a different way. It's formatted in a way that the computer can understand. Now, again, we see it's trying to translate what these hexadecimal digits translate to in ASCII, but it doesn't know, so it adds a little dot. It's not sure what that is. Okay, that's because this is not a plain text file. It shouldn't be able to translate it. And as you see, you kind of get gibberish over here on the right. Okay, but ultimately in this file, what is stored is just binary data, just like a plain text file. It's just binary data stored, a series of ones and zeros stored on the hard disk. Okay, so a text file is by definition also a binary file because everything stored on the computer is binary. But when we say text file, it's the assumption is that there's a specific format of that file. It's formatted in a certain way. When we say binary file, we're generally talking about how a computer can recognize the file. But there's lots of different ways to organize a file. For example, an image, right? How would you organize the data to compose an image? There's lots of different image file types, right? So all of these different file types have a different syntax and a different system. Okay, so again, everything in computer science boils down to systems of communication and fundamentally numbers, right? So let's take a look. I think we're probably about done for this video, and I'll post another one to follow up on this.